My name is Alex Thomas. I'm here presenting for WiseCube. I'm the principal data scientist at WiseCube, and we're here to talk about um, uh, how you can go beyond ChatGPT or other LLMs in biomedicine by combining it with other data sources. So I'm joined here with Seth Rosen. He's software engineer here at WiseCube. He's going to be presenting a lot of the stuff here today because he's done the lion's share of the work. So I'm going to start with an introduction and let's get started. Okay, so yeah, we want to look at question answering with LLMs and other data sources. And the reason why we want to do that, so here's a quick outline. We'll be going over the introduction, natural language, Sparkle, and then how we're federating that with other Q&A. So there's other projects that look at combining LLMs with external data. So for example, Amazon has a project called Retrieval Augmented Generation, which is where they're using external data sources to augment their prompts. And that's great. And we've seen a lot of great work with prompt generation recently, but we're also interested in using LLMs as a way to query the other data sources. So the idea is that there's this feedback loop between the data sources and LLMs. So we can use LLMs as a natural language interface for a variety of different data sources. And so the idea that we're sort of talking about here is having a singular query that is federated out to multiple data sources as well as an LLM. So you can get structured results, you can get documents from an index, and you can get generated answers. So why do we need to have these multiple systems? So here we have sort of a modern interpretation of something like CAP theorem from databases. Here we have CAS theorem. So the idea is that LLMs, they're trained on these gigantic data sets, and they're able to answer questions on a wide variety of domains. And they turn, pretty fast. Most questions are turned in less than a few seconds. But there's a con to them. They can hallucinate. So if you ask them a question that they don't know the answer to, they're perfectly willing to make one up. And that's not good. So we need something that's going to improve the accuracy of these answers. So knowledge graphs are a way to do that. And the reason why it improves accuracy is that what's in a knowledge graph is going to be curated. Now, of course, there can be different levels of trust on the organizations or teams that build these curated data sets, but at least you know that the data that's gone in there has at least been considered by a person. And it also has pretty good speed. So the queries for triple stores or other graph databases usually return again in less than a few seconds. Yes, there are some queries that might be a little more intense, but yeah, generally it's very fast. But of course, it does have an incompleteness issue, and this is dependent on data availability. So if you want to cover a particular topic, you need to go find the data for it, and that can be difficult. So the balances out with the LLM because the LLM can try and answer things from data that you might be have a little bit less availability on. But the graph can help ground it. Now, semantic search, so this is using document indexes, provides a similar benefit. Again, these articles have gone through some sort of a publication process. Depending on the source of your data, so in the biomedical field, it's going to be scientific data. So usually it's gone through a rigorous review process, but there's also preprints, and that's been a little bit less reviewed. But they've at least all been considered by a person, and they offer another balancing to knowledge graphs, in that knowledge graphs will have a lot of particular data that's available in structured format. But there's also a lot of information that's just published in articles that's never really fully converted into structured data. So it provides also a balance to increase the completeness of those two data sets. And of course, in searching through an index is very fast. But there is also a limit to its completeness. If the corpus that you're using does not cover a particular topic, you obviously can't get any answers from it. And a lot of these semantic search techniques also rely on particular NLP models. Now, of course, with the as I'll talk about later, there's been some very good developments in using LLMs for search that's helped alleviate that a little bit. So we take these three and we combine them, and then we can get completeness, we can get accuracy, and we can get speed. So what we're going to talk about here is just combining these two, which is the graph Q&A and the text Q&A. And that can, of course, be extended in the future if there's other particular kinds of data sets you want to. But this idea of the federated QA using LLMs, knowledge graphs, and text is very promising. We're going to be showing one of sort of like the biggest difficulties in doing this. So when you have a knowledge graph, in our case, we're using an RDF knowledge graph. You need to query it. Now, querying RDF is done with Sparkle. Sparkle is a language that looks like SQL but is not, and in fact is very distinct from SQL. There's, for example, no real from clauses. I mean, if you sort of get into some of the more advanced uses of it, you can use from, but for most cases, you're just querying all from one place. And so all the work of Sparkle is being done in the where clause, where it has these series of constraints. And so that's sort of where I think we switch off. And I think Seth, is going to take over from here.
Yeah, so the two main approaches that we've kind of, with the rapid advancement of pre-trained LLMs, are either a direct approach where you kind of break up a graph or feed the whole graph in, similar to the like OpenAI SQL translation example that they have in their like graph and whatever Sparkle schema you're using, and have it generate Sparkle. Both of them have pros and cons. The direct approach is better for small graphs because, one, you're answering the questions directly based on the information. So there's less chance of hallucinating, and it will likely be like it will likely answer correctly if the graph information you have is correct. But it fails as graphs get bigger because, one, there's just more that you need to feed in, so the cost goes up. And two, you have to have efficient ways of breaking up the graph to feed in as context. And then the indirect approach, it's better because you can scale it and adapt it to whatever knowledge graph or domain you're interested in, and it allows for more complex queries than just direct answering. But it's also a harder problem, so there are more places for it to go wrong, and it requires more specific training data and examples. And so in the next, I don't know how many slides, I'm going to go over natural language to Sparkle, like the pipeline that we've spent the last few months really building, starting with an intermediate representation between natural language and Sparkle. And in that, I kind of cover the issues with having the LLM just go straight to Sparkle from natural language, and then explaining why our choice of SetBuilder notation is one of the better ones that I've seen. And I mean, we have some results to back that up. And then from that, I'll go into entity linking, which is how we go from our SetBuilder to Sparkle. And I'll talk about index-based approaches. There are other approaches that people could use, but this is the one we found, and then some of the other uses of entity linking. And then at the end, I'll go over the difficulty of, like, the difference in difficulty for Sparkle queries, as well as some results and how we score things. Okay, so some of the LLM issues that we've run into with, well, just generally, but also specifically with natural language Sparkle, is that sometimes LLMs don't always follow instructions that they're given. So sometimes it'll claim that something can't be represented as Sparkle, or it will try to answer the question instead of translating it, or it just makes up entities or general hallucinations. And so part of that is coming from its limited knowledge of Sparkle query formatting. And since there are multiple different schemas, it is, even when you expressly or explicitly state which one to use, it can combine different schemas, which will give a malformed query. Sometimes it places the subject or the predicate in the wrong position, which again makes a malformed query. Occasionally, I've run into cases where instead of using constant variables throughout, it will just create a new variable for each line. And so it's returning, well, if it returns something, it's returning a ton of information or it just fails. And then I've also had it fail to add operators and filters to ensure that the results it returns are relevant. Okay, so another issue that I've kind of run into with my testing of pre-trained LLMs is that it doesn't know, it lacks knowledge of the target graph. So it doesn't know how we store the entities or the URIs, which causes it to hallucinate graph entities. And some of the most extreme examples I've had of that are if it doesn't have the entity provided as a context, it will just make up something. And I think, random World War II entities in my testing that GPT came up with. And so, the issues are hallucinating. It will make up predicates and it will create malformed queries that don't follow a particular schema for whatever graph you're using. And some of these issues can be alleviated by providing context of the graph, but it is marginal. You get marginal returns as the graph gets more complicated and also as the query gets more complicated. So to solve some of these issues that I just mentioned about LLMs, we tried a number of different intermediate representations. And the one we've seen the most success with is SetBuilder notation, which is a mathematical notation that describes sets by either enumerating its elements or stating properties, which is what we really care about. And and then in the green box is kind of the natural language to intermediate that I'll talk about next. So the reason I chose SetBuilder is one, it retains natural language elements in a structured format, which preserves the positional context of things. So if you're talking about the active ingredient in a drug, it will keep that positional context rather than invert it and potentially be wrong. It's also good because SetBuilder notation is a lot more common than Sparkle. So there are definitely more examples in most of the pre-trained LLMs like training corpus. And so we don't need to give it a ton of specific Sparkle or graph entities. We just have to have it learn the SetBuilder notation that we care about. It also relieves the hallucination problem since it doesn't need to produce URIs or entities. It's just restructuring what was in the original natural language query. And then on the right, I have an example. So which genetic variants of EGFR are positive therapeutic predictors for both erlotinib and lapatinib? And so the SetBuilder for that is every X such that X is a genetic variant of EGFR and X is a positive therapeutic predictor for erlotinib and X is a positive therapeutic predictor for lapatinib. And then from the SetBuilder, it goes to the Sparkle and it kind of shows, how you can go from natural language to the SetBuilder to the Sparkle in a logical fashion. Okay. So in addition to using our intermediate representation, providing context to the LLM drastically improves results. So if you just ask if you ask a pre-trained LLM to generate SetBuilder for the question, what genes are associated with autism spectrum disorder, it's pretty likely that you would get the first one in blue, which is every X, such that X is a gene associated with autism spectrum disorder. And so that, while correct in English, it's missing everything in the red box on the right because it's not getting the subtypes of autism spectrum disorder. And once we include some custom schema and some examples, the LLM will create the second one where it's getting every X and Y, such that X is a gene associated with Y and Y is a subtype of ASD. And this example is just highlighting how important context and examples are for more complicated queries. Okay, so next I'm going to talk about entity linking. And entity linking is a necessary step because the LLM generated SetBuilder notation is using natural language labels for graph entities. So we still need to obtain the graph URIs to construct Sparkle. And we do this using an index-based entity lookup. But again, people could use other approaches should they want to. So entity linking helps to account for variation from LLMs. And since most of the pre-trained ones are being updated every so often and just pushed out, there's increased variability. Even if you see an improvement between your own test 1 and 2, it might fluctuate when a new model is pushed out. So we have some of the entity linking rules help to account for things like that. It also allows for heuristics to help the natural language to Sparkle process for standard practices in Sparkle that it's not learning because we're having it go from natural language to SetBuilder, or that we haven't really given it examples for. So some examples are like select versus select distinct, filtering results based on the language that you want, and then also adding in things that are common practices in Sparkle or in your graph representation for links that aren't necessarily explicitly stated in a question. So genes that encode a protein that's a part of a process, or subtypes of a parent entity, such as diabetes mellitus being the parent class, and then type 1 and type 2 being subclasses. And since, if you ask a question, what are the symptoms of diabetes, and don't provide type 1 or type 2, an LLM might just answer for one or the other and not give you the full answer. Okay, so in addition to the things that I just talked about, entity linking also helps to correct some of the common mistakes made by an LLM that we haven't trained out yet or can't be trained out. So things like predicates that have general labels and it gets confused, so it uses the wrong one. Predicates that aren't used in a graph but make sense in natural language, or like English predicates in a sentence, it will sometimes use. LLMs, like the pre-trained LLMs, really get stuck on certain action words. So like blocks and inhibits are two examples that I've seen a lot where we don't have that as a predicate because it's represented somewhere else. But LLMs are getting stuck on those words. And then it also helps to correct for entities that have multiple instances with the same name or similar names. So a gene found in a human versus a gene found in a mouse will have the same label, but if you're asking about a disease or something related to humans, you want to make sure to get the human gene. Same thing with any of the proper nouns versus proper noun being journals like cancer versus cancer the disease. We have to have a way to make sure that it's getting the right one, since the label in natural language is the same. Okay, so there are multiple levels of difficulty for Sparkle queries that we have to cover. And a lot of the standard machine learning approaches out there for natural language to Sparkle pretty much cover the single hop with, pretty good accuracy. Between like 70 and 90%, they're able to transform natural language questions into single hop Sparkle, which are simple queries. It gets more complicated as you add more constraints. So going from single hop to what we call like heuristic hop or multi-hop, which is single hop with an additional constraint, such as like, for example, what genes are associated with autism spectrum disorder in that previous example. You have to get the subtypes or like the subclasses of that parent disease. So it's not inherently harder. It's just a half step more that you need to do to get the full answer. And then from there, we can go into multi-hop, which our example is what are the molecular functions of the protein encoded by the gene EGFR. So you have to take the gene EGFR and then get whatever proteins it's encoding. And then from there, you get the processes that are the functions of that protein. So it's 3 hops. And I think, there's a kind of a plateau effect where the more hops you add, the less likely it is to be a coherent natural language question. And I think maybe around like 4 or 5, it starts to like flatten. And then I don't know of any real examples of like 7 hops, because at that point it's just a little bit too much. And then there's also a different like formation of Sparkle that we can do, which is statement to statement. And our example is what is the cellular target of gefetinib? So instead of doing like entity, predicate, entity, you have to do entity, statement to entity, and then from there another statement. So it's just splitting what would be one predicate into 2 like half predicates to get to the answer that you care about. And so it's a little difficult to score Sparkle because of how many different ways you could approach the same question, right? So you can use inverses on predicates. You could go through like auxiliary entities, which is similar to the statement to statement thing that I was just talking about, where, you would have an entity and then a predicate linking to that entity. And then from the middle entity, you could get to the third entity, or you could just go directly from the first to the third, and both would be correct. And then it's also difficult because not every link between things is the same. So you may have a link, like you may have genetic association between 2 things. And then for another example of the same type, you would have to do statement to statement, and both would be correct. But because they're different, it's more difficult to score it. And so my example of this is for a drug, X is an active ingredient in Y versus Y has active ingredient X. You'll get the same results, but you're approaching it from different directions. And so we've had to account for that. And I think we're pretty close to a custom heuristic or a custom scoring metric, not heuristic. And then for results, it's a lot less difficult since, it's basically, did it return the right information or not? However, returning incorrect information and claiming it's true is more detrimental than returning partial information that is correct. So if you expect to get 5 different things and you return 3 of the 5, we want that to score better than if you return every disease, including the like 5 that you care about. You would have, I don't know, some number over the amount, and it would have to be scored accordingly. So my example is if you expect diabetes but return all of the diseases, including diabetes, the correct answer is there. But again, the other entities are incorrect, and someone may take that and assume that they are correct. So we have to account for that. Okay. And then these are some results from our last 3 rounds of testing on 1,014 examples of varying difficulty. I want to say it's like 100 or so of the single hop, and then the majority of them are the like heuristic or multi-hop, where they're more difficult queries. And so in our first round, we got 53 correct and 26 partially correct. With the partially correct it's returning a portion of the correct answer, but nothing incorrect. And then after adding in some additional examples, we went and doubled that to 103 correct, and then 53 partially correct. And then our third round of testing, where we introduced some of our heuristics and other, additional features around entity linking, we went from 103 correct to 376 correct. And then we went down from 53 partially to 30 partially correct, which, the decrease in partially correct is good because of how much we increased our fully correct answers. And the heuristics also helped to decrease the number that we fail to create Sparkle for by a sizable amount. So, this is just showing that both adding examples to your prompt and all of the additional heuristics that you can add in the entity linking portion, it's showing that they matter, both matter equally.
Okay, so now that we've seen all the work and all this stuff that Seth has achieved in graph Q&A, we want to be able to combine that with another data source. Now, text Q&A is something that I think probably a lot more people are working on, so this is a little bit more well-trodden ground. So natural language to Sparkle, as we just talked about, that's good for getting structured data and also some data that we actually extract from the text and put into the knowledge graph. But the corpus data, the text data, document data, gives information that can't be extracted, that may be harder to even represent in the graph. And so it fills in some things that the knowledge graph data won't have. And the other way, there's obviously huge amounts of data that's in that structured data that's never explicitly mentioned in the document. So these two things definitely combine very well as far as for data sources. And then when you combine that with LLMs, we get the benefit we talked about earlier. So let me talk a little bit about the text Q&A that we're doing. So there's two sort of ways of looking at Q&A. There's closed book, which is where the system does not have access to the documents. If you do this with LLMs, you have a big danger of hallucination. And another problem, which I think is maybe not quite as frustrating, but is perhaps a big loss of a feature, is it doesn't come with sources or references. Maybe you can get an LLM to also generate a reference, but that's going to put a lot of effort and create even more danger of hallucination. OpenBook lets the system access some text or some of the documents in order to construct the answers. Now, the construction of the answers can either be through extracting actual text from the data or through generating. So if you are doing this, hallucination is going to be less likely. And this can be added on top of a feature of search. I'm sure everyone watching this has used Google before, and you've typed in a question to Google and gotten a bunch of documents, but at the top, you also get an answer. So this is something that can augment sort of well-known technology. So the way that we're achieving this open book plus semantic search is we're going to do open book LLM Q&A. So the way that works is that we do a semantic search on the documents. So the way that's done is that you sectionize the documents. You then vectorize the sections and store those. You then also want to vectorize the queries as they come in. So these vectors provided by LLM encode semantic information, sort of. So when you're querying, you're not required on just keyword matching. You're actually getting a more deeper match. So once these results come back, you get the relevant documents for your query, but also you get the relevant text necessary to answer your question. And so then we take these results, both the answer and the documents, and we combine it with the results from the graph Q&A. So the way this works is that you have a system that expects the questions, and you can ask it to either go to the text or the graph. We also allow a fallback system so that you can say, okay, I'm just interested in the graph Q&A, but if that doesn't return an answer, ask the text. And you can also, of course, ask both, and the results will be combined. And as you may imagine from this system, adding a third source, if you were interested, would be very easy. And so this is what I like so much about the system is that both the text Q&A, the graph Q&A are extensible in as themselves. You can add more documents, you can add more corpora. For a graph, you can add more data sources and unify it into a singular graph. You can extend the schema. And then with the federated Q&A, you can actually add completely new data sources or access patterns. So this is very easy to continue to expand going into the future. But for now, we have this demo. So let's switch over to that. So here we have a notebook where we're going to be showing how we access this, how we query this system. We have a singular question here, and we're going to be querying these different methods. So here we have, is pregabalin effective for treatment of patients with restless leg syndrome? So we have the first method, which is going to do the actual query. Now, since this question is a yes or no question, we see that it does come back with this sort of like singular result, which we can interpret as a yes, it is an effective treatment. And if we don't want to actually do the query, we can also just do an explanation. So see what the SetBuilder notation and what the sparkle that get generated look like. And then for the text Q&A, we can just query and get the documents. And so here we have treatment of restless leg syndrome with pregabalin, a double-blind placebo-controlled study. That seems pretty relevant. Comorbidities, treatment of pathophysiology in restless leg syndrome. That seems good. They mentioned pregabalin as well. And so we can also have it generate an answer. So here it says treatment, that document 1, the treatment of restless leg syndrome with pregabalin, provides evidence pregabalin is an effective treatment for patients with restless leg syndrome. And pregabalin is mentioned obviously multiple times in this document about it. So we have these different results. We can also just combine them. So here I'm going to make a query to the combined endpoint, and I'm going to say, okay, mode, I want both. So it returns the explanation for the graph QA, the results of the graph QA, the answer, and the documents. And so having an API like this will let us power a user experience that will be able to combine a wide variety of answers. So someone will be able to come in and ask a question. They won't need to learn a new query language like Sparkle. They won't need to learn how to query a new type of index. They just ask a question, and we will provide structured data. We'll be able to provide documents, generated answers, and also in the future, even more sophisticated insights that we're looking to add to the system. So yeah, it looks like we have one question here from Sujun Jang, which is which LLM is being used and what types of knowledge are stored in the knowledge graph? So that's a great question. So we're using currently for this demo, we're using OpenAI models. So for the creation, so in the graph Q&A, we're using which model is it again specifically, Seth?
Right now we're using the GPT 3.5 Turbo.
Gotcha. And I believe in the I forget which one specifically we're using in the text, but I believe for the actual Q&A part of it, where it says where we're asking it to answer the questions, I believe we're using version 3 at the moment, and we're looking towards.
Yeah, we're using DaVinci 3 for the like answering, but I think we're using their like embedding model for other parts.
And now, as far as for what knowledge is stored in the knowledge graph, there's really like a wide variety. We have like 40 million like specific entities. It's actually 80 million once you have sort of like these meta entities, these statements and stuff I was mentioning. You have like 1,000 different predicates between those entities, and even more when you count like the properties we store. So, this is combined from wiki data, from clinical trials, from Uniprot data. Like, there's a wide variety of different data sets go into the graph, but it's primarily stuff like an entity in property, or an entity in relationship to another entity, and also literature information. So like a document, and the authors and the journal and stuff like that. So that's what's in the. How you try this on your own graph? Yeah, I think so. I think for the text part, that's going to be done on a corpus. Seth, yeah, we want to give some like description of how they could implement it on their own graph.
Yeah, so the natural language to Sparkle QA, you would basically just have to, find the relevant things that you want to be answering on your graph, and then come up with some good examples to give to an OpenAI model, and then do like a few shot learning, and then improve from there once you have a pretty solid baseline of results for questions that you want to answer on your domain.
So that's going to be dependent on the actual data source. So some data sources have a very slow cadence, as in they're released like weekly or even monthly, whereas others have much more rapid cadence. So we try and make sure we have like a full refresh every week. Yeah. So, but yeah, like I said, some data sources don't refresh at that speed. So usually to run Sparkle queries, you start with an ontological model. What ontologies are you using? So the model that we're starting with for that data is we're starting with the Wikidata model, and what we do is we extend that as necessary depending on what's supported by the other data sets that we bring in. I am not familiar with that acronym. Fortunately, I have Google at my fingerprints. We are bringing in. We are working on trying to bring in a wider variety of bioportal data sets. So we've not brought in a lot. We've brought in. So that's why I looked it up. We've brought in. Was it clinical cancer treatment outcomes ontology? Because that was part of a particular project we were doing. But yeah, we're one of the good things about bioportal. Yeah, okay, there we go. So we have brought in that one bioportal data set, and we're working on trying to bring in others. It's good that bioportal is it's pretty easy to access their data. So yeah, we're looking to use more. Current average accuracy of answers. So Seth, I think you want to address that?
Yeah, I don't remember for the doc QA, but for the natural language to Sparkle, we have gotten accuracy for the like simple questions, single hop of anywhere between 80 and 90% for, again, fairly simple questions, which I've read papers out there that had similar results. And then for any of the more complicated ones, like 2, 3, 4 hops, our accuracy is currently around like 35 to 40% on a pretty diverse and complicated set of questions. And we're looking to improve that going forward.
So could you speak to the difficulties or advantages of using SetBuilder? How did you try those how did you try using those in your Sparkle queries? I wasn't clear on that, Seth. So that's from Kevin Clancy. So yeah, so I think Seth, you probably can answer that one best.
Yeah, I don't know how much I'm supposed to give away here, but basically we did a bunch of testing. We started with trying to do natural language directly to Sparkle and had a lot of issues. And then from there, I think Alex tried a couple of different mathematical, like not equations, but ways of like structuring things. And then I had like a memory flashback of one of my college courses about SetBuilder. And so I was like, oh, maybe we could try this. And then, I started testing it, got good results, and then I ran a larger test set and it was way better than any of the other approaches we had currently tried. And so I think the biggest key is that one, the LLM doesn't have to generate anything. It's just reordering what's in the question into a structure that's more suitable for Sparkle translation.
Yeah, I think when you're doing experiments, you're starting with like I'm not sure if, how many heavy linguist people are here, but with Montag grammar, and that of course it looks very similar to SetBuilder notation. I think that must have triggered the flashback. So the next question is: when doing few shot learnings for generating Sparkle queries, could you also share how many examples you give that work the best from your experience? From Jue Hong Nguyen. So I think right now we're still sort of like growing the examples. Right now we haven't hit that point of diminishing returns for number of examples. Even though I know that Seth, you've been looking at sort of like there's both like the number of examples, but also diversity of examples.
Right, and one of the things I've been like running into is inverse examples. So I need to add some of those.
Am I giving
And
an example
so
of that?
yeah, so all of the examples I have are approaching the question from one direction. But then if you ask a question that wants, instead of what diseases does a certain drug treat, if you want all of the drugs that treat a certain disease, it will run into more errors because it doesn't have that example yet. But the example I showed with autism spectrum disorder, I gave one example and like a brief overview of SetBuilder notation and our custom schema, and it immediately, got the right answer. So the few shot learning with the GPT 3.5 has been really good. And, adding, I think, I don't know, maybe 10 examples between my first round of testing and second, and it doubled the number correct. So, adding examples, even if it's relatively few, is probably going to have a huge impact as like at the beginning. I expect it to kind of fall off as I cover more diverse groupings.
So roughly at this point, like what? Because I know that you're obviously working on a new round of experimentation. What's the sort of like the order of magnitude of number of questions? Have we like crossed 100 yet?
No, I don't even think we have more than 25 examples right now. I mean, so like we have 25, maybe 25 questions, but we have to provide the answer for each of them. So that's why,
Yeah.
the prompt token size is growing faster than the actual number of examples, especially for the more complicated queries that we want to answer.
So next question is, I was wondering what your opinion with using a weighted graph based approach as opposed to Sparkle queries. Well, so one of the benefits of Sparkle instead of just like a mainstream triple store is that it also supports sort of what we'd call like an advanced user feature, which is like for those people that do know how to query graphs, they can just go in there and query it. We are looking at techniques to add more weights to the relationships. Specifically, there's off this paper from a few years back. I think it's 5 years old, 6 years old, something like that, from Google, where they're essentially using like link prediction to try and assign weights to all their edges. and be able to incorporate that sort of those sort of weights in the future. And we're doing actually a lot of other experimentation with link prediction right now. But yeah, right now we're not using a weighted graph at the moment. Okay, well, I would like to thank everyone for attending, and thank everyone for all the great questions. And let me add this. And if you want to know what to do next, you can follow our blog, which we sort of talk about the cool stuff that we're doing. And if you want to get in touch with us, have an email address up there. It's info@wisecube.ai. Also, I think it was on one of the little splash banners here. And we plan on making this slide deck available. I think we'll probably I'll sort of leave it to Zakaria, like how we're going to share it. But yeah, thank you everyone for attending.